Improper integrals. We know that definite integrals can be used to evaluate areas. Consider the graph of y equals 1 over root x, defined for x greater than 0, which is shown below. Suppose we wanted the area shown in this diagram. We could do that by evaluating this integral. Integrate between the limits 1 and 3, our function 1 over root x dx. But suppose instead that we want the area shown here, where this area just goes off forever in this direction. So we're starting at 3, but essentially going to infinity. So the area would be the integral from 3 to infinity of 1 over root x dx. One of our limits is infinite. The way that we deal with this is that we do the integral from 3 to a of 1 over root x dx, and then consider what happens as a tends to infinity. If doing this gives us a realistic value, we say that it converges. But doing this may lead us to an infinite value, in which case it doesn't converge and we can't use the method. We would also have a problem if we wanted the area to the left of the area shown in the diagram. In other words, this area here. That would be the integral from 0 to 3 of 1 over root x dx. The problem here is that the function 1 over root x is undefined when x equals 0. In other words, the y-axis is an asymptote. The way we deal with this is to do the integral from a to 3 of 1 over root x dx, and then consider what happens as a tends to 0. Once again, this may give us a nice value. In other words, we have a convergent integral, or it may not. So to reiterate that point, if the limit provides us with a finite answer, we say the integral is convergent and we get a useful answer. If the limit does not, then the integral is not convergent and we can't do it.